Hello. In this demo, I'm going to use the Parasoft C++Test CT on a C++ project with unit specifications created under the Boost.Test unit testing framework. So we're going to use this example project here. First, we just clone the project. Next, let us try to build a project without using Parasoft just to make sure that the project builds without compiler errors. And as you can see, the project is using the Boost unit testing framework. The executable of the main application is generated in the bin folder, and the Boost that has this cases executable is generated in the test folder under the build directory. Now let us try to run the both that test unit test cases. And the test cases have been executed without errors. So the project builds and compiles correctly. So the structure of the project is the source code is here, and then the test cases are in the test folder. All right, so let's clean the project and start it all over again. Now that we've seen the project builds without any compiler error, transforming this project and using the Parasoft C++Test CT to generate code coverage metrics uh, is involved in minor changes. First, we just copy the Parasoft provided CMake file. I already have a copy of the CMake file. I'll just copy the entire folder here. First, let me create a Parasoft folder, or you can create any folder name as you wish. Now, I will copy a Parasoft provided CMake file. This file is installed in the path where you install the Parasoft C++Test CT. So in my system here, it's here. So the Parasoft provided CMake extension can be found in the integration folder CMake. Now I will use the version of this file, which is all I already modified to fit my build environment here in Linux. All right. So this file that I copied here is exactly just the one that is provided by Parasoft, except that I modified a bit the provided CMake to match the compiler family that is active in my Linux environment here. If I type GCC version I'm using 11.40. So I have to modify a little bit, and only this modification is needed in this example. So if you open the parse up, I modified the value of the compiler ID to match the, the one that is in my operating system. After copying the CMake, the Parasoft provided CMake extension, we need to modify a little of the existing CMake of the both the test example project. You can see that this project has an existing CMake list.txt. We'll open this CMake and we will insert in the appropriate location, probably somewhere here, and put this statement here to include the parser provided CMake file right there. And you'll notice that this inclusion of the parser provided CMake is protected by this variable flag here. I will save CMake file and I will type get status. So we can see here that the changes that we have made so far is we copy one CMake file under this Parasoft folder, and then we adjust a little bit the existing CMake list.txt of the project. Now it's time to build the project again, but this time enabling the build of this project with Parasoft instrumentation. To recall, we have to enable this flag to run to activate the custom CMake that is included in the project's main CMake. The enabling of this flag shall allow the proper operations that inserts instrumentation into the generated executable to gather code coverage. Now that the make files have been prepared in the build folder, we can now build the project as usual. Just as before, the bin folder has been generated for the main project executable, as well as the Boost.Test uh, executable file under the build folder. Now, in order to run or generate coverage log, we need to execute the Boost.Test executable file. Now, just like before, the test cases has completed and there is no errors detected. However, because this uh, both the test has been instrumented with Parasoft, we can compute the code coverage as a result of this execution. To do that, we'll have to do CMake, build, build, and then select the target, coverage compute. This command here is the only command in the Parasoft C++ test CD that requires a valid license of the tool. And as you can see, the execution of the command is checking the license, which I have, and then computing the code coverage. Now that the code coverage has been computed, it is time to generate the report. I'll run again the command, however, selecting a new target, report, and then we can see here the code coverage of different types in the execution of the test cases. There's also a more presentable HTML report of the coverage. By typing Chrome and then coverage.html. You can see here that with little bit of changes in the CMake list and the inclusion of Parasoft custom CMake extension, we successfully converted an existing C++ project with Boost.Test unit test framework, and its execution resulted to the report to the creation of coverage reports on different metrics, from line coverage, statement coverage, block coverage, decision coverage, simple condition coverage, MCDC coverage, function and call coverage. Take note that by default, none of these uh, exotic type of code coverage is possible, and only Parasoft, it is only through Parasoft instrumentation that this code coverage has been computed. Thank you.